There is a star you can see tonight, with your own eyes, that is already dying. When it finally dies, it will burn so bright that for weeks it will cast shadows at noon. It will hang in the daytime sky like a second sun that refuses to set. The only question astronomers can't answer is the one everybody asks first. When will Betelgeuse explode, and what happens to us when it does? Find Orion on a clear night and look to his shoulder. That deep orange point of light is Betelgeuse, one of the largest stars we can see anywhere in the sky without a telescope. It is a red supergiant, somewhere around 16 times the mass of our Sun, and it sits at the very far end of its life. And it is enormous. If you swapped it for the Sun and dropped it into the center of our solar system, its glowing surface would reach out past the Earth and swallow the orbit of Mars. Whole planets would simply be inside it. This is not a star like ours. It is a dying giant, running out of time, and we have a front row seat. To understand why Betelgeuse is doomed, you have to understand how a giant star burns. Stars live by fusing light elements into heavier ones, releasing energy that pushes outward and holds the star up against its own crushing gravity. But the heaviest element a star can profitably make is iron. A star this massive races through that ladder of fuel. Hydrogen first, then helium, then carbon, and on toward iron, with each stage burning faster and hotter than the one before. The hydrogen can last millions of years. The final stages can last only months. Betelgeuse is thought to be in a late stage of this process, very likely fusing carbon deep in its core right now. And when the core finally fills with iron, fusion stops paying its own way. The outward push collapses, and the star can no longer hold itself up. What happens next takes less than a single second. The iron core implodes, falling inward at a fraction of the speed of light, crushing itself denser than an atomic nucleus. Then it rebounds, and a shock wave roars back out through the star and tears it completely apart. We call this a Type II supernova, the violent death of a massive star. And here is the part that matters. That Betelgeuse will end this way is not a guess, and it is not a maybe. It is settled physics. A star this big has only one ending. The single thing we genuinely cannot pin down is the date. And for a few strange months, it really did look like the date might be now. Beginning in late 2019, Betelgeuse started to fade. Not a little. By February of 2020, it had lost roughly 2/3 of its visible brightness, dropping so far that the change was obvious to the naked eye. The slump was so dramatic it earned its own name. The Great Dimming. Across the world, astronomers and sky watchers alike wondered out loud if they were finally watching the countdown to an explosion in real time. They weren't. When the biggest telescopes on Earth turned to investigate, the culprit wasn't collapse at all. It was dust. Betelgeuse had violently ejected an enormous cloud of hot gas from its surface, which drifted outward, cooled, and condensed into a veil of dust grains that hung directly in front of the star. From our point of view, that veil simply dimmed the light. Hubble and ground-based observatories traced the entire event from start to finish. The star didn't almost die. It sneezed, and by spring it had fully recovered to its normal brightness, as if nothing had happened. Then, in 2025, the story turned again. Astronomers using the Gemini North telescope reported the probable direct detection of something people had suspected for decades but never confirmed: a companion star. A small, hot, blue-white star locked in orbit around the giant, hiding for a century in its glare. They nicknamed it Siwarha. And in January of 2026, observations from Hubble added more evidence that it really is there, circling its enormous neighbor. The companion matters far more than it sounds. Siwarha orbits surprisingly close, so close that it may actually move through Betelgeuse's bloated outer layers as it travels, and it may even help explain some of the giant's long history of strange flickering and dimming. But here is the crucial part. The discovery muddied the timeline. Some researchers now suggest the companion implies the supernova will have to wait, that Betelgeuse is simply not as close to the end as the most dramatic forecasts had claimed. One discovery, and the clock got blurrier, not clearer. So here is the honest answer to when. We do not know. The conventional, long-standing estimate is that Betelgeuse won't explode for around 100,000 years. But some studies of the way the star pulses and breathes have argued the end could come within mere tens of years. And still others place the window somewhere across the coming centuries. After the companion star news, the scientific consensus drifted back toward much later. Probably. But probably is not, certainly. The honest truth is that on a human scale it could happen tonight, while you are watching, or it could happen long after our entire species is gone and forgotten. But picture the night it finally does happen. Over the course of hours, a new point of light flares to life in Orion's shoulder, brightening and brightening until it rivals the full moon. Except that all of that light is squeezed into a single, searing point, instead of a soft disk. It would be plainly visible in broad daylight, a star you could point to at noon. At night, it would be bright enough to cast hard, sharp shadows on the ground, shadows you could read by. For weeks, the Earth would have a second source of nightlight overhead, and then, slowly, over months, it would fade back into the dark. And the question you are really asking, underneath all of it, what happens to us? The reassuring answer is almost nothing dangerous. A supernova would have to go off within just a few dozen light-years of Earth to seriously threaten life here. Betelgeuse sits somewhere between roughly 550 and 720 light-years away. Its exact distance is honestly still debated because measuring the distance to a star this swollen and unstable is genuinely hard. But either way, it is far, far outside the danger zone. There is no radiation to fear, and no shockwave that could ever reach us. You could simply stand outside and stare at it with the naked eye, completely safe, in pure awe. And what it would leave behind is its own kind of beauty. The explosion would scatter the elements forged inside the star, out across hundreds of light years of space. The carbon and oxygen and iron that become the raw material of future planets and future worlds. And at the very center, the crushed core would most likely survive as a neutron star, a city-sized object so impossibly dense that a single teaspoon of it would weigh about as much as a mountain. This is worth sitting with. The atoms in your own hand, the iron in your blood, the calcium in your bones, were all made exactly this way. Inside stars that lived and died long before the sun was ever born. So tonight, go outside and find that orange star on Orion's shoulder. It is already living on borrowed time, a doomed star you can see with your own two eyes from your own backyard. And here is the strangest thought of all. Because its light takes centuries to reach us, it is entirely possible that Betelgeuse has already exploded. that somewhere out there a brilliant new light is racing toward us right now, and the news simply hasn't arrived yet. We won't know until it does. And that, more than any countdown, is the honest wonder of the cosmos. The future is already up there, written in light and traveling toward us, and we are still waiting to read it. This channel publishes the honest cosmos every single week. The verified, the theorized, and the genuinely unknown, always marked clearly and never overstated. Subscribe so you don't miss the next one. One question before you go. If you knew for certain that Betelgeuse would explode within your lifetime, would you want to know the exact date, or would you rather be surprised? Tell me in the comments.